Salam, peace be upon you. My name is Muhammad Laik Siddiqui, the father of Holophase. Remember the language we are learning. There is one field, phi, the holophase, the single cyclic movement from which all reality unfolds. When phi differentiates, that one movement generates its first derivatives, and with them, the three dimensions appear at once: time as omega, space as k, and motion as v. From that first differentiation upward, every higher derivative is an echo of the one below it, an infinite ascent of finer and finer reflections of phi's original movement. And because the dimensions are born from that first echo, time, space, and motion also reverberate into infinity, carrying phi's unfolding into ever deeper rhythms, structures, and flows. Thus, the entire universe, every law, every pattern, every force, every particle, every phenomenon, is nothing but phi, endlessly echoing through its derivatives and their dimensional shadows. All of existence is the infinite echo of one field. Today, we listen to just one of those echoes. In our last exploration, we climbed the first flight of the temporal tower. We sat with omega as the local rhythm of time, and with alpha as the acceleration of that rhythm, the way the universe's heartbeat can speed up and slow down rather than ticking at a fixed mechanical pace. We learn to feel that time is not just a passive background, but something that can tighten and loosen, compress and stretch, as phi turns with changing intensity. Now we turn our gaze from time's tower to its majestic counterpart, the spatial tower. We walk sideways, away from clocks and beats, and lay our attention on the shapes and textures of the world. There, the first letter we met was K, the basic spatial texture, the measure of how quickly phi changes as you move from point to point. Today, we take our first step upward from that foundation. We move from K, the fixed texture, to its higher echo, A, the drift of that texture. If K is the pattern painted on the canvas of reality, then A is the slow sliding and reshaping of that pattern. It is the quiet, patient drift of spatial form, the way patterns do not only exist, but also migrate, deepen, blur, or sharpen across the fabric of space. To feel A in your body, imagine you are standing barefoot on a beach, close to where the waves have just pulled back. The wet sand holds delicate, parallel ripples carved by the rhythm of water and gravity. Those ripples have a particular spacing: crest, trough, repeating along the shore. That spacing, that local rhythm in space, is what we call K. It tells you how quickly the sand's height rises and falls as you walk. If the ripples are fine and close together, K is large. If they are broad and gentle, K is small. Now a steady wind begins to blow along the shoreline. After a while, you notice that the ripples are no longer fixed. They creep, almost imperceptibly, down the beach. The pattern itself is sliding. The crests shift by a grain's width, then another, then another. If you could speed up time as if watching a time lapse, you would see the entire field of ripples marching slowly along the coast. That slow migration, that drift of the pattern itself, is what we call it. A photograph of the sand would show you K, a frozen texture. A time lapse, where the same pattern shifts and transforms, would show you A. In this sense, A answers the second question that space can ask. Not just, what is the pattern here, but how is this pattern changing as we move from here to there? The universe uses A to say, not just pattern, but patterning. Not just shape, but shaping. Inside the holophase language, this difference becomes grammatical. We are slowly building a vocabulary in which each derivative plays a role similar to parts of speech in ordinary language. In the temporal tower, omega behaves like the noun of time, the basic word for tempo, and alpha becomes the adverb that modifies it, telling us whether that tempo is speeding up or slowing down. In the spatial tower, we find a beautiful symmetry. K is the noun of space, the fundamental word for texture or spatial rhythm. A is the first adverb that attaches to it. When we say, the field has stripes, we are using K. When we say, the field has fine stripes, we are specifying the magnitude of K. But when we say the field has stripes that become finer as you move to the right, we are using A. We are no longer describing just the pattern at a single point, but the way the pattern evolves as we move across space. That shift from what the pattern is to how the pattern is changing marks the step from first order to second order semantics. It is the difference between saying the terrain is hilly and saying the hills are getting steeper as we walk north. In the master tree of phi and its derivatives, this role is drawn very clearly. K grows as the first branch in the spatial direction from phi, and A grows directly above it as the next branch. We first ask, how does phi change across space? And we obtain K. Then we immediately ask, how does that spatial change itself change from one place to another? And we obtain A. In this lineage, A depends on K the way the drift of a melody depends on the melody itself. You cannot speak of a drifting pattern without first having a pattern. A gives K depth, directionality, and narrative. From the scientific point of view, we can describe A operationally as the spatial derivative of K, the gradient of texture. K already measures how quickly phi's phase changes as you move through space. A measures how that rate of change varies from place to place. Picture yourself as a tiny ant walking along a corrugated metal roof. The distance from one ridge to the next under your feet defines K, the spatial frequency you feel as a regular up and down motion. If, as you walk, those ridges stay perfectly equally spaced, then A is zero. The texture is uniform. But if the ridges gradually come closer together or spread farther apart as you go, then you are feeling A. It is the way the underlying texture itself changes along your path. Or think of a glass prism splitting white light into a rainbow on a wall. Different colors separate at different angles, each corresponding to a different wavelength and therefore a different K. The smooth spread of colors from red through orange, yellow, and green to violet is a spatial gradient in K. That smooth gradient is making the spectrum a continuous band rather than a set of isolated stripes. In the mathematical language underneath this audio journey, A is part of the full gradient of K. K can be represented as a vector that points in the direction where phi increases most rapidly, and A tells us how that vector changes as we move. In other words, A encodes spatial modulation. It is what turns a perfectly uniform pattern into a living, evolving one that focuses, defocuses, sharpens, blurs, bends, and twists. Every letter of the Holophase language must echo through time, space, and motion simultaneously, because all three dimensions arise together as different shadows of the same underlying field. So how does A appear in time? Most vividly, it shows up as the time evolution of spatial texture, as the visible story of patterns changing their shape. Imagine watching a drop of dark ink fall into a clear glass of water. At the moment it enters, the ink forms a sharp, intricate cloud with strong gradients. The local K is large near the boundaries where ink meets water. As time passes, the cloud expands and softens. The sharp edges blur, the gradients become gentler, and the fine filaments dissolve into a more uniform tint. What you are watching is K changing in time. The rate of that change, the way the pattern smooths or spreads or curls, is the temporal expression of A. Or think of a satellite movie of a storm system spiraling over an ocean. The bands of cloud around the center have a certain spacing. That is the K of the storm. As the storm intensifies, those bands tighten, wrapping closer to the center, and the spacing changes. The speed at which those bands draw together or stretch apart is a speaking through time. In the time dimension, A gives patterns a life story, an internal biography. Without A, patterns would be static wallpapers. With A, they breathe. They condense into sharp structures, disperse into haze, twist into spirals, or unfold into filaments. A is why coastlines grow intricate under erosion, why clouds billow and never repeat, and why no frozen snapshot can fully describe a living world. In space, A appears as a literal map of how texture varies from place to place. Consider running your hand along the back of a zebra. Near the shoulder, the stripes might be wide and widely spaced, corresponding to a smaller magnitude of k. As you move toward the flank or the legs, the stripes often narrow and their spacing changes. The rate at which that spacing changes as you slide your hand is A. It points in the direction where the change in pattern is strongest and has a magnitude equal to how quickly that change happens. Or imagine a photographer adjusting a camera lens. Slightly in front of or behind the focus plane, the image is blurred. Light from a point source spreads into a fuzzy circle because many different k values are contributing. At the exact focal plane, that fuzz collapses into the sharpest possible point, meaning k is tightly organized there, and a momentarily drops to zero. As you move away from that plane, the degree of blur changes, and that changing blur is a field over space. In all these cases, it constructs landscapes of concentration and dilution, places where detail piles up and places where it thins out. It is the architect of gradients, drawing invisible arrows across space that say, here the pattern thickens, here it relaxes, here it turns. In motion, A reveals itself as the quiet guide that shapes how things travel through patterned environments. Motion, in the Holophase framework, which we call V, is derived from the relationship between omega and k. It tells us how fast you must move to stay on the same phase crest. When A modifies k, it also modifies those motion instructions. Think of a surfer reading the surface of the sea. On a perfectly regular swell, where every wave crest is equally spaced and aligned, the surfer can move in a relatively straight line, matching a nearly constant k and v. But real waves change as they approach shallow water. They steepen, their spacing changes, and they often curl into tubes. That changing wave texture is A, and the surfer's curved path, carving along the face of the wave, is a direct response to it. Or imagine sound moving through air with a temperature gradient. In warm air, sound waves travel faster. In cool air, they travel more slowly. Where there is a vertical temperature gradient, there is also a gradient in the effective K experienced by the sound waves, and thus a non-zero A. As a result, sound grays bend toward the cooler region, curving instead of traveling in straight lines. This is why you can sometimes hear distant sounds more clearly at night or across a lake. In motion language, A is what makes trajectories respond to texture. It is why light bends when it passes through a gradient index lens, why cars slow down when the road surface becomes rougher, and why animals and humans follow gradients of scent, food, or safety across their environment. Movement becomes a conversation between V and the slow drift encoded by A. Within the master tree, A occupies a very precise and beautiful position. Earlier in our journey, we built the first floor of this tree. Phi as the silent root that carries everything. Omega as the first temporal branch. K as the first spatial branch. D phi as the unified spacetime change. And V as the emergent propagation meaning built from omega and k together. That completed the core alphabet, the first order semantics. Then we stepped into chapter 3, the nuance block of second order semantics. We first climbed the temporal tower and met alpha, the change of temporal tone. Now we stand in front of the spatial tower. Its structure mirrors the temporal one. At level 0 sits phi, the single field. At level 1 sits k, the basic spatial texture. At level 2 sits A, the drift of that texture. And at higher levels rise curvature, convergence, shear, twist, and more intricate shape descriptors. A is the gateway to this infinite tower of spatial nuance. It represents the moment when we stop asking, what is the shape here? And begin to ask, how is this shape shifting as we move? It tells us that space, in the Holophase view, is not a rigid, empty container, but a living fabric whose textures can slide, stretch, and rearrange. Because the tree is interconnected, A has rich relationships with neighboring branches. Its closest relative is K, its parent, from which it is derived. A is literally the change of K. Its deep twin is alpha, the temporal second derivative of phi, which does in time what A does in space. Both are second-order letters. Both describe how a first-order quantity bends or drifts. They often appear together when patterns evolve in spacetime, with alpha describing how the rhythm changes and A describing how the spatial fabric reshapes in response. A also interacts strongly with V, the propagation meaning. Since V depends on K, any gradient in K, any non-zero A, can act like a slope in the landscape that motion naturally responds to. Things roll down gradients of texture the way water flows downhill, even when what is flowing is not matter, but phase, information, or energy. Looking ahead, A also feeds the next spatial letters we will meet. Curvature is built from how A itself changes. Convergence and divergence describe specific ways patterns accumulate or disperse. Shear and twist capture the sliding and rotational aspects of drifting textures. All of these are formed by repeatedly asking the same question. How does this change change? A is the first answer to that question in the spatial tower. Even d phi, our unified spacetime differential, contains within it components that are shaped by A. As d phi tells us how phi changes along any path in spacetime, A helps determine how the spatial portion of that change varies from place to place, influencing which paths are straight and which feel like climbing a hill. Because Holophase is meant to be a scientific language, not just a poetic picture, we must also ask how A can be stable, how it can vary, and how it can be tested. When A is zero, we have the ideal of pure uniformity, a perfectly regular lattice, a flawless sine wave filling all space, or a fluid with no gradients of texture. In these cases, K may be non-zero, but it is constant, so the pattern repeats without drifting or reshaping. When A is non-zero but constant, we obtain simple linear gradients, a wedge of glass whose thickness increases steadily from one side to the other, a room where temperature changes at a constant rate from floor to ceiling, or a cylinder whose surface markings tighten at an even rate from base to tip. In such systems, the gradient is stable and predictable. Most natural systems, however, exhibit changing A. Their gradients bend, intensify, or relax as you move, and the drift of texture has its own drift. River deltas, where sediment patterns rearrange. Mountain ranges that soften from jagged peaks to gentle hills. And tightly focused laser beams, where the intensity pattern changes rapidly near the focal point, are all examples where A itself varies and points toward curvature and higher spatial derivatives that we will explore later. Crucially, A is falsifiable. In any system where we can measure K, the local spatial frequency of a pattern, we can also ask whether K changes smoothly and in what way. Pattern gradient tests look at how K varies across space and compare that variation with the predictions of a model built from phi and its derivatives. Other tests follow waves as they bend, focus, or spread when they cross regions where A is expected to be non-zero. And they track how structures emerge in systems that self-organize into patterns. Consistency checks compare different ways of inferring A, directly from images, from how waves refract, and from how tracer particles move in the field. If these routes disagree in a systematic way, if we observe pattern changes that cannot be represented as smooth derivatives of K, then our understanding of A, or of the underlying phi, must be revised. If you want to see the precise equations, definitions, and experimental proposals, you can search for Holophase on Zenodo. There you will find the formal scientific papers that anchor this spoken journey in careful, testable, operational detail for working physicists. Once you begin to look for it, you can also feel it in everyday life. Look at a tapered candle. The wax near the base is thick and broad, while the tip narrows. The way this thickness changes along its length is a simple, tactile example of it. Stand in the middle of a straight road that stretches to the horizon. Near you, the road appears wide. Far away, perspective makes it seem to converge to a point. That apparent change in width as a function of distance is a geometric illusion driven by a change in the effective K on your retina, and your brain automatically reads it to build a sense of depth. Listen to the siren of a passing ambulance. The Doppler effect does not only shift frequency in time, it also compresses sound waves in front of the vehicle and stretches them behind it, creating a spatial gradient in wavelength that is in the air around the siren. Rake sand in a small garden, drawing parallel lines with the teeth of the rake. If you move in a straight line, the lines are evenly spaced, and K is constant. If you slowly rotate your wrist as you walk, the lines curve and their spacing changes. You have just drawn an A field by hand. Examine a vinyl record under magnification, and you will see a spiral groove that looks almost regular. Yet in sections where loud sounds were recorded, the groove wiggles more tightly. The variation in wiggle spacing is a microscopic signature of a stamped into plastic. Each of these examples points to the same insight. A is not just the presence of pattern, but the presence of patterned change. To become fluent in reading, you can adopt simple habits. Whenever you encounter a repeating pattern, on a wall, in fabric, in clouds, in leaves, in sound, ask yourself, does this repetition stay exactly the same as I move my eyes or my body, or does it change? If it changes, in spacing, orientation, contrast, or clarity, you are seeing A. When you walk from a smooth floor onto a rough one, pay attention to how the sensation under your feet changes along the boundary. That tactile gradient is A. When you stand at the edge of a forest and look out over a meadow, notice how the density of plants, the size of leaves, or the thickness of branches changes as your gaze moves. That is A at work. Run your fingers slowly along the grain of a piece of wood, or across the threads of a woven cloth, or along a brick wall where the spacing is not perfectly uniform. In every subtle shift, your senses are detecting A, the gentle drift of space's pattern. Over time, you begin to experience space itself as alive, full of gradients and quiet flows, instead of as a static container in which things merely sit. As always, we close by returning to phi itself. Everything we have described, K, A, the drift of patterns, the guidance of motion, the focusing of waves, is not a separate substance or a second field layered on top of reality. It is all phi, seen through different lenses of differentiation. In the spatial lineage, phi is the silent cyclic field. K is its first spatial echo, answering the question of how phi changes across space. And A is the second echo, answering the question of how that spatial change itself varies. No new stuff appears at A. We simply uncover more detailed information about phi's spatial dance. A is phi saying, not only am I textured this way here, but my texture evolves as you move. This is the deep economy of the holophase language. Infinite richness generated by repeatedly asking refined questions about one underlying movement. A is the second question in the spatial series. Curvature will be the third, and more will follow. Yet through all these layers, it remains one field, one cyclic order, unfolding as an entire cosmos of shapes, gradients, and flows. So as we end this part, hold the image of space not as a rigid stage, but as a flowing fabric whose patterns drift. We began our episode by seeing the whole master tree. Then we learned the core alphabet of phi, omega, k, d phi, and v. Then we stepped into second order nuance by meeting alpha, the change of temporal tone. Now we have met alpha's spatial twin, A, the drift of spatial pattern. A is the gateway to spatial dynamics. It is where description of form begins to transform into explanation of formation, where geometry begins to grow into morphogenesis. In the next part, we will climb one step higher and meet curvature meaning, the letter that tells us how slopes bend and valleys hold, how lenses focus light, and how orbits trace their graceful paths. But for now, remember this simple truth. Space flows, space gradients, space focuses. Whenever you see stripes that tighten toward an edge, whenever you feel a floor tilt beneath your feet, whenever you watch light bend in shimmering hot air, you are witnessing a... Whenever you trace the grain in wood or follow the flow of a crowd through a city, you are reading a... You are watching phi answer its second spatial question about itself. You are hearing the adverb that modifies space's noun. You are seeing the drift in the fabric of reality. A is space's drift, and that drift is the beginning of guidance, the seed of structure, the first hint of why things are shaped the way they are. Salam and peace be upon you until part 11.